Alright, this is a video for Blended Algebra 2, Unit 1, Lesson 1, which is Introduction to Functions. Let's start with some vocabulary about functions here. So the first one is a relation is any set of ordered pairs. So ordered pairs are points like x, y, or 3, 1, something like that. And any set or group of points is called a relation. The x-coordinate, or the input of a relation, is called the domain. We'll deal with that in Lesson 2. The input is always the x variable. Alright, this set of y-coordinates, the output, is called the range. Again, we will talk about domain and range in Lesson 2. The output is always the y variable. Okay, so now, a very specific, type of relation. This is what the whole lesson today is on. A function is a specific type of relation where every element of the domain corresponds with exactly one element of the range. So let's simplify that here. Every x value has only one y value that goes with it. So no x value will ever repeat. We'll see that when we look at some examples. Now there's a test we're going to use down below to decide if something is a function or not, and it is called the vertical line test. The vertical line test says that if you draw a vertical line through a graph and it crosses the graph in more than one place, like here it crosses 2 times, then that would not be a function. We would say it fails the vertical line test. And we'll see that again in just a second down below. Alright, so now we want to tell things are functions. So let's put that definition of a function to use. Remember, the definition of a function says that every x has one y value that goes with it. So when I look at a set of points, this is what we have in number 1, 0, 0, 3, 0, 3, 10, and 5, -3. I want you to start by looking at the x-coordinate of those ordered pairs. First thing, when you look at this set of ordered pairs, you need to figure out, do any x's repeat? That's your first question to say to yourself. Well, notice here, the x value of 3 repeats in both of those ordered pairs. And there are different outputs, different y values. That breaks the definition, because the definition says every x is only one y value, and this had 2 different ones. So in number 1, we are not a function. Now number 2 is a table. We do the same kind of thing. We want to look at the column of x values here. Now when I look at those x values, none of them repeat, which means every x only matches with one y value. So yes, this guy is a function. All right, number 3 and 4 are graphs. We're going to use the vertical line test here. I'm going to call it the VLT. So basically what that says is if I draw a vertical line anywhere on the graph, notice here it only crosses the graph 1 time. So that is a function. On number 4, same idea. If I draw a vertical line anywhere on the graph, it only crosses once. So that is also a function. All right, flip your paper over. Now let's talk about function notation. If we know how to tell if something's a function, then we can evaluate functions. So function notation looks like this. It is called f of x. Whatever is going to be inside the parentheses is always an x value. We're going to spend some time with that. And whatever the function equals is your y. So let's see how to use function notation. Let's start with this function called f of x. F of x is 5x minus 2. So we want to find f of 3. Now that 3 is inside the parentheses, so it is an x value, which means that you're going to take that x value and put it in for x into the function. So you will have 5. Now instead of x there, remember we're replacing the x with 3. and then we'll have minus 2. Now you just simplify. You can use your calculator or you can do it in your head. 5 times 3 is 15, minus 2. 15 minus 2 is 13. 13 is your output or your final answer, your y value there. So 13 is the y value that goes with the x of 3. All right, same thing for negative 2. The negative 2 is in the parentheses, so you put the negative 2 in for x. So 5 times negative 2 minus 2. Well, 5 times negative 2 is negative 10 minus 2. And negative 10 minus 2 is negative 12. That would be your final answer. So that was the example for f of x. Now if we change the function, let's try g of x. G of x here is x squared plus 4. So again, the 6 is in the parentheses. That is going in for x. So I'm going to put 6 here squared plus 4. Notice that I wrote 6 in parentheses. Anytime you're going to square a number, I want you to write it in parentheses so that you make sure you type it into your calculator correctly. 6 squared is 36 plus 4, and 36 plus 4 is 40. When I do g of negative 1, this is where those parentheses are going to be really important. We're going to put negative 1 in for x, write it down with parentheses when you square it. That way, when you type parentheses negative 1 squared into your calculator, you get positive 1 plus 4 equals 5. Remember, when you square a number, that means you are multiplying it by itself. So technically, we have negative 1 times negative 1, which is positive 1, which is how I got the 1 there. All right, finally, let's look at h of x. H of x is the square root of 3x. So let's put 5 into this function for x. We'll do the square root of 3 times 5. Both numbers are under your radical. That's going to simplify to radical 15. Now, we haven't gotten to square roots yet in our class, but we're going to leave that answer as it is. The square root of 15 does not simplify. All right, finally, h of 0. The 0 is also an x value. So I'm going to put it in for x here. We'll have 3 times 0, and 3 times 0 is 0. So I have the square root of 0, which you are allowed to do. The square root of 0 is 0, and that would be your final answer. And remember, that final answer is a y value. If I plotted this, I would have the point 0 for x, 0 for y on your graph. Well, that's pretty easy. When I have function notation, if I have a number in the parentheses, I can stick it into the function. But now, we're going to kind of go backwards. We're going to switch things up a little bit. This time, I'm going to start with the function f of x is 5x minus 2. And the directions here say, find x. That means you do not know what x is. So when I have this negative 27, it says f of x equals negative 27. That negative 27 is not in the parentheses. It is what we equal, which is a y value here. Remember, the answer for the function is always a y value. Since I don't know x, I can't put anything in for x there. So the way I'm going to write this is I'm going to take my function 5x minus 2, and I'm going to set it equal to negative 27. That is saying, in a math sentence, 5x minus 2, what do I put in for x here to give me an answer of negative 27? Well, all we have to do is solve that equation. So we'll start by adding 2 to both sides, which gives us 5x is negative 25, and then divide by 5. That tells me the x value of negative 5 is what I'm looking for. Okay. So if I put negative 5 into this function up here for x, you will get an answer of negative 27. Same idea for g. We have the function g of x is x squared plus 4. And the directions say find x when g of x is 53. Remember, when we're not in the parentheses, when we're just set equal, that is a y value. So you take that 53 and you set it equal to your function so that you can solve for x. Now here, to solve this one for x, we're going to start by subtracting 4 from both sides. 53 minus 4 is 49 equals x squared. And the opposite of squaring something, the way we get rid of that squared, is to take the square root. Well, x equals the square root of 49, which is 7. So 7 would be your final answer. All right, last problem here, the square root of 3x is h. All right, we are going to find, it says find x when h of x is 6. So one more time, that 6 is not in the parentheses. It is a y value. So you're going to take that 6 and set it equal to the function that you're starting with, 3x. Now you want to square it to get rid of this square root. So we're going to square both sides. And that gives us 36 equals 3x. That's the stuff under the radical. To get x by itself, you divide by 3. And you get 12 equals x. That is the x value that you were looking for. All right, so we have talked about so far the definition of a function, how to know by looking at graphs if something is a function or not. Now we've done a little bit of function notation from equations. How do I put an x value into a function? And how do I find an x value when I'm given the answer? Now let's look at a table. Functions also can be done with tables. So let's see, example 3. Boiling water at 212 degrees. So a pot of boiling water is left at room temperature. Temperature readings are taken every hour. Right? So we have hours here on the top and temperature on the bottom of the table. So first thing it says is find T of 2. What that means is find the temperature after 2 hours. The input here, T of H is for hours. Right? That's your top one. So that means you're going to take 2 as your input. Well, when I go to my table, if I look at 2, the output is 104. So the temperature after 2 hours is 104 degrees Fahrenheit. Same idea here with the temperature after 6 hours. I go to where 6 is on my table, and I find that the output is 68 degrees Fahrenheit. This time we're going backwards. It says for what value of H, that means you don't know the hours, is the temperature equal to 76? Well, I find where the temperature is 76, and it looks like the time there is 4 hours. Those go together. And finally, it says between what two consecutive, consecutive means two numbers that are next to each other, between what 2 hours will the temperature be 100 degrees? Well, let's look at our table here. It looks like I'm going to hit, my temperature starts at 212 over here and goes down. So 100 degrees is going to be somewhere in between 104 and 85 degrees, which means that the hours you are between, that would happen between 2 and 3 hours. So that's how you can do function notation with the table. As long as you know what the input is, you can just look at the values that they're given. Lastly, let's do some function notation from a graph. Great. So, first of all, the question says, is f of x a function? Well, that's when you have to use that vertical line test. If I come over here and I put a vertical line anywhere on the graph, notice that each vertical line only crosses one time. So yes, this is a function. We can tell because the graph passes the vertical line test. We're going to abbreviate that as VLT. Now, we want to evaluate based on our graph. It says evaluate f of 1. Remember from a few minutes ago, the 1 is an x value because it's in the parentheses. So I go over here to my x-axis. The x-axis is your horizontal axis. I'm going to darken in real quick for you here the axis, so you can see that's where the zeros are. And if I go to where x is 1, right here, I need to go up to my graph to find the output. So if I'm at x is 1, I went up 1, 2, 3, 4 to get an output of 4 for my graph. Right? If you need to, think about it as an ordered pair. X of 1 has the y value of 4. Same idea for f of negative 1. Negative 1 is an x value. If I go to where x is negative 1 here, it looks like I don't have to go up or down to get to my graph because the output there is going to be 0. I didn't go up or down. Finally, f of 5. 5 is also an x value, so I count over 1, 2, 3, 4, 5. And I have to go down 1, 2, 3 to negative 4 to get my output. So that point there would be 5, negative 4. Now it says, let me erase some of this here. The next one says, what is f of 0? Well, 0 is an x value. So go to 0 here, and it looks like I have to go up my graph 3 spots to get to that output. Well, that point, the ordered pair is 0, 3, and it goes through the y-axis. That is called your y-intercept. Right? That's a feature of this graph. Now the next question is a little bit trickier. It's asking you, what values of x, okay, what values of x, so we do not know the x value, solve the equation f of x equals 0. Well, a couple problems ago, we said whenever you're finding the value of x, what the equation is equal to is a y value. So we want to know what x values give us a y value of 0. Well, y values of 0 are right here along the x-axis. That's where the y values equal 0. So we want to find all the points on our graph that give us that output of 0. So that's where they cross. So it looks like there's one right there, right here, and right there. So the x values here, well, this one on the left, that looks like it's going to be at negative 1. The second one right here, if I count over, is at x equals 3. I'm just going to list them. And then 4, 5, 6, 7 is the last one. So there are 3 places where an x value gives you a y value of 0. And those are all the x-intercepts of the graph. So you can do function notation from an equation, you can do function notation from a table, and now from a graph. Let's do the last problem here. Example 5. All right, evaluate each of the following. F of 0 again. That 0 is an x value. So you go to your graph where x is 0, and it looks like you have to go up 1, 2, 3, 4 to get an output on the graph. At negative 3 for x. If I go to where x is negative 3 here, it looks like I have to go down 1, 2 to get an output of my graph. And then f of 4, we go over to 4 here, and I have to go up 1, 2, 3, 4, 5 times to get an output. So the next question says, find the values of x when f of x equals 2. So same thing we did in the last problem of example 4. This 2 is a y value, it's what you equal. So I want you to draw a line where y equals 2 is a horizontal line going through the y-axis, and that's where y equals 2. Now, notice, you cross, those 2 lines intersect. Right here, 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 and there. There are 4 places where the x value gives you an output of 2. So we need to find those x's. This point right here is negative 5, 2. So the x value that goes with it is negative 5. This next ordered pair is negative 1, 2, with an x value of negative 1. The next output here is at x equals 1. And then the last one is at x equals 3. If you need to see that, remember, that's the point 3, 2. These all have y values of 2, then the x values we wrote down. Finally, how many values of x? So this is asking a different question. They're not saying what values of x. They're saying how many values of x does f of x equal 3? Well, 3 is a y value. So every time they ask you for the y value, go to your graph and draw a line where y equals 3. Now they just want to know how many times do those two lines cross each other. So it looks like they cross each other for 3 values of x. All right, those are the notes on function notation. If you have questions on those, please see the teacher and then go ahead and try the practice for function notation. If you need more help on the practice, the key is posted on Canvas as well as a practice video.